Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide focusing on DTC C1243-12, indicating a high voltage signal from pressure sensor 2 on the Honda Civic 2022 and onwards. Understanding this error code begins with knowing that the brake booster pressure sensor is crucial for ensuring effective braking. This sensor monitors the pressure in the brake system, providing essential feedback to the electric vacuum pump control unit. When the output voltage from brake booster pressure sensor 2 exceeds a specific threshold, the control unit detects this anomaly and triggers the DTC. The purpose of this guide is to walk through each aspect of diagnosing and resolving the issue, ensuring vehicle safety and performance are restored efficiently. The DTC C1243-12 pertains primarily to the brake booster pressure sensor 2, which plays a key role in measuring the brake system's pressure. Located typically on the brake booster, this sensor helps in providing accurate data to the electric vacuum pump control unit. If the sensor's output voltage exceeds designed parameters, it signals a malfunction, which prompts the control unit to store the DTC. Additionally, the electric vacuum pump control unit is responsible for managing the electric pump that assists in brake operation. The check valve, integrated within the intake manifold, ensures that vacuum pressure is maintained effectively, preventing backflow and ensuring the proper function of the braking system. Troubleshooting this DTC involves checking these components for possible faults. Several factors can trigger the DTC C1243-12. Firstly, a high voltage signal detected from the brake booster pressure sensor 2 is the primary reason for this error code. This could stem from a malfunction in the sensor itself or an internal fault. Additionally, wiring issues may exist, such as damaged or shorted wires that could cause false signals or excessive voltage. It's also essential to inspect connectors and terminals for corrosion or looseness. Lastly, if the brake booster pressure sensor has failed or is faulty, it may provide incorrect readings, thus resulting in the high voltage signal. Thorough examination and identification of these possible causes are essential in effective troubleshooting. When the DTC C1243-12 is triggered, the symptoms may manifest in various ways. One of the most significant symptoms includes braking performance issues, which could lead to decreased braking efficiency and safety risks while driving. Drivers may also notice the electric vacuum pump cycling on more frequently, working harder to maintain vacuum pressure in the braking system. Additionally, the warning light on the dashboard may illuminate, serving as an alert to the driver that there is a fault within the braking system. Understanding these symptoms can help drivers identify when to seek mechanical help. As such, promptly addressing this code is essential to ensure safe operation of the vehicle. The first troubleshooting step involves manipulating the vehicle's ignition settings. Start by turning the vehicle to the on mode, which powers up the electrical systems, allowing the vehicle's control units to initialize. After a brief moment, transition the vehicle to the off mode, ensuring that all systems shut down appropriately. It is crucial to wait for at least 2 seconds before turning the vehicle back to the on mode. This step serves to reset the vehicle's electronic systems, which can sometimes resolve transient faults or erroneous readings that might contribute to the DTC being stored. By following this procedure, technicians create a clean slate for the next steps in diagnosing the issue. The next critical troubleshooting step involves inspecting the electrical circuits corresponding to the brake booster pressure sensor 2. Begin by verifying the sensor 2 signal and sensor 2 ground connections for any signs of an open circuit. Open wiring could lead to the anomalous high voltage readings, triggering the DTC. Performing an open wire inspection means checking the continuity of the circuit, wherein you should find that the resistance is less than 1 ohm. If you measure any higher resistance or complete open circuits, there is an issue with the wiring that needs to be repaired. This testing is crucial as it isolates potential problems before moving on to inspecting the components themselves. Following the circuit checks, the next logical step involves inspecting the brake booster pressure sensor 2 itself. Mechanics should conduct a thorough inspection to identify any failures or irregularities in sensor operation. The confirmation procedure dictates that if DTC C1243-12 is still not indicated, the external circuit must be functioning normally. This procedure means the sensor is effectively communicating with the control unit as designed. If DTC C1243-12 reappears, it implies there is a fault within brake booster pressure sensor 2 itself, necessitating replacement or further testing. Proper diagnosis of this component is critical as it directly influences braking performance. Finally, if the previous inspections pass, attention should turn towards the check valve, particularly in conjunction with the intake manifold side. Begin this step by ensuring the engine is running before conducting a test drive. During the drive, accelerate until the turbocharger engages, allowing real-time testing of vehicle performance under load. After the test drive, observe whether DTC C1243-12 remains illuminated. If the DTC returns, there may be a malfunction in the check valve, which can preclude proper vacuum and lead to issues in the brake system. Conducting a functional test drive is essential for capturing faults that may not present during stationary diagnostic checks. After completing all necessary repairs and inspections, it is crucial to verify that everything is functioning correctly. Begin this verification process by clearing the DTC from the vehicle's system, resetting the electronic control units. Following this, ensure that the brake system is operating smoothly and effectively, checking for any signs of malfunction or warning lights reappearing. Conducting a final test drive is essential to confirm that the DTC C1243-12 does not return and that the vehicle's braking system performs reliably under various conditions. If all checks are satisfactory, the issue has been resolved. This verification step ensures a comprehensive approach to vehicle repair and promotes long-term reliability. To prevent future occurrences of DTC C1243-12, regular preventive maintenance is key. This includes routinely inspecting electrical connections and wiring to the brake booster pressure sensor 2 to ensure they remain intact and free of wear or corrosion. Monitoring the performance of sensors is also vital. Keeping an eye on their readings can help catch potential faults before they escalate into DTCs. Additionally, ensuring that connectors are clean and free from debris is crucial for optimal electrical conductivity. By optimizing the performance of these critical components, vehicles can run safely and efficiently, minimizing unexpected failures and enhancing overall reliability. In conclusion, effective resolution of DTC C1243-12 relies on a thorough understanding of relevant components and their functions in the braking system. Each troubleshooting step must be carefully followed to accurately diagnose and rectify the issue related to the brake booster pressure sensor 2. The importance of preventive maintenance cannot be overstated, as regular checks can significantly reduce the likelihood of future DTCs. By understanding symptoms, possible causes, and implementing robust inspection routines, vehicle owners can ensure their Honda Civic remains safe and dependable on the road. Ultimately, addressing DTCs promptly and efficiently safeguards both the vehicle and its occupants. please like and subscribe to the channel. See you next time.